Good morning and welcome back to the SAIC studio. If this is your first time joining us live, we are broadcasting from SAIC's headquarters located in Reston, Virginia. I'm Manmeet Singh, account manager for Coverse and SAIC Company, and joining me today is SAIC's chief data scientist and director for strategy for artificial intelligence, Meil, an awesome guy and somebody I admire, and actually lots of people I admire in SAIC, but you're one of the top guys.
Thanks, Manmeet. I appreciate it. I'm happy to be here.
Yeah. So awesome. There's a lot of commotion about AI ML. Everybody wants to talk about it, but we're going to filter through that noise and focus in on unlocking the power of AI for the mission accelerators. That's something our customers want to know more about, so we'll try to stay away from the noise and be mission focused.
So you mean no ChatGPT-3 discussions?
No. We'll leave that for later. So how is the federal government leveraging data and AI to improve decision-making process? Let's set the foundation for our discussion today.
Yeah, so really good question. I'd say first, let's talk about what artificial intelligence really is and what artificial intelligence isn't. And for those who've heard me speak before, I talk a lot about this, setting the scope and expectations around AI. So the idea that when most people think about AI, they think about, dystopian futures and AI taking all the jobs and not allowing humans to make decisions. But right now, where we live and exist today, AI is very narrowly focused. So it's powerful. We see large language models and different abilities to generate, but it's very narrowly focused in that it solves very bespoke and specific problems one step at a time. We're not to the point where we've reached this concept of generalized artificial intelligence or artificial consciousness or the ability to have the machines understand what they are, that they exist. And so this narrow focus, living in this world where we are today, we need to think about how there's utility to using artificial intelligence and leveraging it. And so for me, I think we need to focus on things like reducing cognitive load and human-machine teaming, and the ability to augment the way we work in the workplace every day with AI as sort of like a wingman, right? And so what do I mean by all that? Well, we are deluged with data consistently on a constant basis every day at home, in our work lives, everywhere. And so one of the things that AI can do with the human-machine teaming concept is that we allow the machine learning and the computers to do what they do best, which is sort through massive amounts of data, find signals in the noise, or find a needle in the haystack, or extract patterns that then you can pass to the human who is now freed up, doesn't have that massive cognitive burden on them, and they can do the things that humans do best, which is strategic thinking and reasoning and decision making.
Yeah, no, absolutely right. There's also a term I've come across as artificial hallucination, right? Thinking that it's doing this thing or fear. But also, you talk about data. There's also something we just discussed earlier is superficial intelligence. And that's because your AI is not working very well because the data on the bottom is skunked up, or the quality data that we're looking for just isn't there. They're siloed. It's just unstructured data. It remains unstructured. So how do we address the foundation of data?
Yeah, so that's a really good question. I think a lot of us sort of gravitate towards, hey, let's solve the problem with artificial intelligence. We generally have to walk people back and say, before we can solve the AI challenge, we have to solve the data challenge. So what do I mean by data challenge? We have lots of data. We talk about the 5 V's of data: velocity, volume, veracity, and really how do we get data that we might have tracing back 50 years, but was never designed to go into machine learning models. How do we deal with data from disparate sources that might be very dirty, that might be unstructured, and that might be very segmented off in those silos? How do we bring that all together to create an authoritative source of truth where we have ingested the data, where we've indexed the data, where we've cleaned and conditioned the data, and where we've enriched it and sort of shaped it to a point that we can start doing artificial intelligence? That's really key, and I would say that's one of the primary blockers to getting AI off the ground.
Yeah, absolutely, because most of the people interact with what's on the surface with their user interface, not realize, all the amount of information and algorithms that make it possible for them to have that taste of artificial intelligence, right? That
Sure.
addiction. They're like, oh, this was awesome.
Yeah.
So,
Absolutely.
yeah, no, this is fantastic. Now, going back to our federal government customers, what are the key challenges in implementing AI initiatives and how are they doing it today?
So we talked about one of them, and that was the data problem, right?
Yeah.
Getting a handle on our data, having that authoritative source of truth so that we can do analytics and build models. And we'll talk a little bit about your company, Coverse, and how that solves that problem. And I'd say the other challenges are basically policy-based challenges. So that is, are we allowed to co-locate different types of data? Are we allowed to break down silos? What do data sharing agreements look like between data owners and data custodians? And sharing, between organizations or the Department of Defense or the intelligence community or other federal civilian organizations. And then I'd say the last one that's really important too that I want to touch on is adoption. So adoption of these AI technologies. In the end, if we solve the data problem and we build, applicable mission analytics for an end user, at some point the human still has to decide to use them. So now we have to talk about things like responsible AI. We have to talk about explainability in AI and how it's making decisions so that we can build trust in artificial intelligence. And then we need to talk about how the user actually interacts with it. And that's where Tenjin comes in. And we'll talk a little bit about SAIC's Tenjin as well. But the idea that we need to give the end user the ability to interact with data and interact with models in a way that they understand and that's intuitive and not intimidating.
Yeah. No, so this is fantastic. Now we've got three things that we can talk about. We can talk about Coverse and the data, and Tenjin and the artificial intelligence, and the mission accelerators, which a lot of our viewers might not know what is mission accelerators and how it comes about. So if you can do a little bit of distinguishing all these three layers, that'd be fantastic.
Sure. So Coverse is a company that SAIC acquired about 2 years ago. It provides a data backbone to all the data science solutions that we provide. What it offers our mission partners is true multi-level security solutions. So how can I essentially physically co-locate all of my data from disparate source systems, whether it's structured data like tables, think like Excel spreadsheets, or unstructured data like SharePoints or PowerPoints or PDFs or scanned documents, which most of our data actually is in this world is unstructured, and bring it all together, physically co-locate it, but then be able to logically separate it and disseminate that data and share that data with the right people at the right time. Tenjin is that AI orchestration layer that we talked about. So I think a lot of the people probably joining us today have the same problem on their teams and their organizations. Data science is a relatively young profession. It's very hard to find data scientists. It's even harder to find cleared data scientists. So when we're talking about the spaces that we work very often with our mission partners in the DoD and the intelligence community, so it's a scalability problem. Everybody needs these technologies and everybody wants to leverage these technologies, but there is a real issue with having the right people to be able to operate these models. So what Tenjin does, it was purposefully designed to create citizen data scientists and to empower end users, whether they're technical or not, to interact with data in a meaningful way. And then our mission accelerators are built in within Tenjin. So what we did is we went and talked to our mission partners across our federal civilian space, across the Department of Defense, across the intelligence community, and said, what are the hard problems that you're really trying to solve? And maybe surprising, maybe not, most people were looking to solve the same problems. They might have different data, they might have different reasons, they might have different problems to solve, but it came down to 3 or 4 key, we'll say, subcomponents of artificial intelligence or machine learning. One was computer vision. So that's dealing with imagery. The ability to detect objects in either photos or videos, the ability to segment those objects individually, the ability to classify those objects and label those objects to enrich that data and to make decisions with it. The next one, and the one that's been getting so much press lately, natural language processing, is anything to do with text-based analytics. So the ability to do optical character recognition and take an unstructured document or piece of paper and digitize that text and make it searchable, for example. Or the ability to unlock, and something that Coverse does really great, the ability to unlock insights from data, right, unstructured data, and make it searchable across data sets. So all those 15, 20 years of PowerPoint, SharePoint, scanned documents that I mentioned earlier that you can't search on, using natural language processing to actually unlock the sort of the knowledge within those and make it searchable. And then we have data fusion. And that's a big one that we think is very important. And that is focused on how do we bring, I mentioned narrow artificial intelligence earlier.
Yep.
And so we have different models that solve different bespoke problems. How do we bring all of that together and have one large, what we call ensemble model, to then make a decision about something? So I'll use an example. Let's say we're working with our Department of Defense mission partners, and they are trying to distinguish a particular signal and figure out what that signal is relating to. They might have a model that can look at the waveform and classify what that might be. But at the same time, that might not be enough information for them. So they may need to take an image of something. And then once they have that image, they want to classify the image of whatever that object is. And then they might have some of these PDF reports or something like that that have information about what they're potentially looking for, and they want to extract those insights. And the ability to combine 3 different types of intelligence or 3 different types of inference off of models and then make one big decision that, hey, in fact, this is what I say it is, that's really powerful. So our mission accelerators are solutions that are built into Tenjin, and they are designed and operated in a low-code, no-code way so that anybody can interact with these models and deploy these models.
Yeah. And there's a term you used, citizen data scientist, right? So I want our viewers to really sort of hone in on that and how our philosophy of this AI experience for our customers, for our teammates, is different from other solutions in the marketplace, right? What's driving citizen data scientists?
Sure, it's a great question. So again, it comes down to adoption, right? A lot of data, just the word data scientist is sometimes intimidating to some folks. And so again, it's about the usability. It's how easy and how comfortable I am as an end user to interact with data, to be able to do what I need to do and extract the insights I need from the data, and to interact with the machine learning and artificial intelligence. And again, there are a lot of very powerful products out there that do a lot of really great things. In fact, we partner with a lot of companies that do that, but they don't offer the ease of use to an end user. So it becomes a scalability or an extensibility issue. This really empowers people to do self-service analytics. And the framework that we have built with our technologies, or the scaffolding that we have built with our technologies, creates a repeatable, step-by-step, discrete process where people can come in and extract the insights they need.
Yeah, that's fantastic. Now, how have we seen government missions adapt to more powerful AI tools? How do they deal with their mission? How do they deal with policy? How do they deal with being just simply comfortable with this new age of AI, right?
Yeah, so I think a lot of this goes to what I started to mention earlier, responsible AI. And I think in order to adapt and be comfortable using it and adopting it like we talked about, you have to be sure that the inference that it's giving or the decisions that it's making are decisions that are palatable for you, and they're also accurate decisions. So what we see is in the first wave of sort of this new machine learning, artificial intelligence revolution, it was just about give me a model that does something. So we call those black box models. We didn't necessarily know what was happening on the inside. We didn't necessarily know how models were making decisions. One of the things we're working towards is what we call explainability or invertibility, so that you can trace from ingest of the data to inference on the data what's happening within these sort of systems of systems. Now, we still can't solve, we still cannot explain mathematically what happens inside of a layer of a neural network. If we solve that, we'd be sitting on an island somewhere and spending the rest of our lives in the sun, right?
Yeah.
But what we can do is we can say with a lot of certainty, if I'm able to tell you, I have a model that can put a particular X on your map and tell you where the treasure is, for example, the first thing you should say to me is, prove it. How do I know that that's making that decision, or how did it make that decision? So we've built the capabilities along with some of our partners so that we can walk back and understand, here were my raw data sets, here's where all the data came from, here's how we cleaned it, here's how we curated it. Here are the models that we tested it against. This is the model that gave the best accuracy or the highest level of accuracy. here's why that model gave the highest level of accuracy. Here's how we deployed that model. And you can follow it all the way across, which leads to that trust in artificial intelligence. And I think as the government, back to your original question, as our government partners try to rely on AI more and more, try to reduce that cognitive load, try to build out decision support and COAs, and really start focusing on delivering the right data to the right people at the right time, they're going to have that trust in AI. And again, that can be complicated. So we're able to trace it back, we're able to explain it, but we're also able to do it in a visual abstraction that is really accessible, again, to the low code or no code user who might not be technical.
Yeah, no, that's fantastic. And earlier you also said cleared space, and that's important because we're talking about, we have AI applications in healthcare, on the financial sector, but here in the defense sector, what is interesting is how cybersecurity intersects with AI. And Equator is where I'm going towards. Sure. And if you want to tell our viewers about this technology, because that's our specialization, is to make sure that the customer is comfortable with our AI solution in a multi-level security environment. Sure. And there is trust, because a lot of times the foundation of data is not there, and then it goes to superficial, hey, this thing doesn't do. So let's talk a little bit about Equator and trust and secrecy and all of that other wonderful stuff on the defense side. Sure.
So yes, we deal with a lot of mission partners who deal with a lot of very sensitive data.
Yeah.
And obviously, your company, Coverse, and now part of a wholly owned subsidiary of SAIC, is no stranger to dealing with very sensitive data. The provenance of your company coming out of the intelligence community, the National Security Agency, and the ability to secure data down to that fine-grained level, or what we call the data object level, is so important. So we talked about that physical co-location and the logical separation. That can be in any way, but in this case, we're talking about top secret, and unclassified information being brought together to help make better decisions and to help disseminate and share information. So Coverse has that power, and it's extremely powerful, and it's used today. It's fielded, as you know, in the DoD and the IC and federal civilian organizations, and even some commercial organizations. You mentioned Equator, or what we call EQADR, encrypted query, analytics, and data retrieval. That is a specific integration using Coverse, which we've talked about, Tenjin, which we've talked a little bit about, and another novel homomorphic encryption technology. And what that allows us to do is start sharing data across different boundaries and across different commercial networks, but keeping it fully encrypted and secured in multiple ways. So Coverse is going to keep the data encrypted at rest. We have transport mechanisms that keep the data encrypted in transport. And then the homomorphic encryption actually protects the data in use. So what that means is homomorphic encryption allows you to do the business logic, the mathematical calculations, and all the querying without dropping that encryption. So you get this trust around the data that you can pass it between organization to organization, or between the US Defense Department and coalition, or between other organizations across different networks, and you are fully protecting and securing the information.
Yeah. I wish I could get like Equator on my phone, because if my wife goes through my browsing history, I'm able to keep my searches homomorphic on my phone. I think there's an edge use case over there that I came up with.
Logically separate your searches.
Absolutely.
Based on who's accessing your phone.
Yeah. So there's also another phenomena of no vendor lock, right? We talked about that. This repeating theme again, where right now, whether we look at some of the commercial AI tools that are out there that are giving people a taste of the future, on our customer side in industry, they're saying, hey, we want the freedom to go in horizontally, vertically. So it again goes to the philosophy of SAIC and how we offer our products and solutions to the customers.
Absolutely. SAIC at its heart, we're a large systems integrator. We've supported the defense and intelligence and federal civilian community for decades. And we are very much about interoperability and integrating with systems and not creating any type of vendor lock on any of the software technologies that we bring. So this stack of technologies that we're talking about today, we have deliberately made sure that it's open architecture. And what I mean by open architecture is that it's API based, and that it can interoperate and it can integrate with our partners' systems, both upstream and downstream from where it would sit. So it's never about a rip and replace, hey, if you want these technologies, you got to get rid of what you have and forget about what you've invested in. It's about how do we integrate and phase these technologies in and augment your workflows and what you're doing. So that open architecture and API basis is very important. And then you mentioned vendor lock or data lock. So we shouldn't have to say this, but I think it's important to say that our technologies are designed in such a way that any data that you ingest into any of our systems, any data that you derive, any data products that you derive from our systems, any models that are built within our systems or ported into our systems, and any inference that comes off of those models that have been built or ported into our systems are all our mission partners' technology. It's theirs. If they want to extract their data, they can extract their data. If they want to move a model from one system to another, either they built it in Tenjin and they're taking it to the edge, or they built it in another technology and they're bringing it into Tenjin to abstract it and make it low code. It's really about that interoperability piece and that portability piece so that our partners understand that their data and their models are theirs.
Yeah. And of course, we know there's significant activity happening in Eastern Europe and in the Pacific. And we provide services to our customers, especially on the defense side. But how do these tools help countries talk to each other in a secure way, secure our data, secure our secrets? So if you can enlighten us.
Yeah, so from a tactical or an operational standpoint, in that perspective, with encrypted query analytics and data retrieval, we talked about that 3 levels of encryption. Yep. We can pass information from point A to point B in a way that would be very safe.
Okay,
and protect the information.
And I just want to remind our viewers that feel free to leave comments or ask questions. We are going to address that shortly. As a society, so I'm going to go to a little bit of basic, what my mom and dad and others are thinking, AI is coming, it's going to take our jobs away, it's going to do all of this. That question we keep repeating, but sure. We repeat it because we have to give repeated assurance of this is the new job market, this is what the future is going to look like. The jobs, what we have today, are quite different than what we had 50 years ago. Sure. But that gap is getting tighter and tighter. So how is the AI going to change our livelihoods and the job market?
Sure. So I think that the important thing to note here, especially, society-wide, but also within our mission partner space, nothing that we're bringing to the table is about replacing human capital. It's not about replacing jobs. It's about augmenting workflows and about actually making it easier and less tedious for the human. And again, as I mentioned before, freeing them up to do things that are more valuable that a human can do, vice a computer doing. So is the workplace going to look differently? Absolutely. You jump back to when the personal computer came about and computers became sort of ubiquitous across companies. Did that replace all the people who were working? No, now we just have people sitting behind computers, vice what they had, pre the personal computer era. So I think that there is a fear, and I think we have to have an understanding, and we need to learn how to work with this technology. But I don't think that it's going to replace the human anytime soon. I think it will augment and will make better decisions. And if you think about it, take it out of the work context. When we're not at work, we are interacting with artificial intelligence ubiquitously throughout our day. We have our iPhones, we have our GPSs, we have our Alexas and our Siris and all of that technology that is making our lives easier and augmenting how we live. But somehow we come into these environments sometimes and it's like we jump back in time 20 years. And so this is about bringing technologies to the forefront to help the workers and our mission partners and the warfighter and everyone else out there interact with data the way they would, outside the walls of their work.
Yeah, absolutely. I know there was the Y2K, and then there was like the paperless society, and here I am having a piece of paper. So yeah, all of these can be in tandem. These technologies, they can coexist, and the future can be, with multiple layers of eras, stacked up together. Sure. But Tiffany, are there any questions that we got?
Yes, great conversation. Thank you so much. A question from Elizabeth in the audience. She says, trust and security are key themes for successful AI adoption and implementation. Are there any other considerations? What is the role of automation and cloud?
Yeah, so great questions. Trust and responsibility, absolutely key, and the ethics around all of that. When we start talking about cloud, we need to talk about how do we manage resources better. So, and that's something that the cloud gives us, the ability to, again, I mentioned earlier, sort of a scaffold or a framework. You could look at the cloud that way too. We are taking common resources and sharing them so that we don't have to have the capital outlay or the infrastructure outlay or the human capital outlay of different people setting up bespoke environments again and again and again. So it's really about how do we get more efficient and how do we be more effective at what we do. The other thing is that cloud offers, I think, specific to artificial intelligence, is cloud basically commoditizes two things that are very important for artificial intelligence to actually train models and deploy them. And one is compute, so how much does it take to actually train a model? And the other is storage. You very quickly run out, or you hit, we'll say, fences if you're using systems that are physical hardware. Whereas in the cloud, we can go ahead and we can leverage that infrastructure to be extensible and to be scalable. In many cases, automatically. So when you mentioned the automation piece, there's a lot we can do with artificial intelligence and deep learning to automate workflows. There's a lot we can do using basic things like robotic process automation to integrate other workflows. But that scalability piece, being able to automate the compute that I need to build models or deploy models or to inference with models, is really revolutionary because it makes AI accessible to the masses.
And I'll put a plug in over here for our HR team because, we talk about these are the jobs that are coming. What are the jobs today in SAIC and Coverse that if somebody said, hey, this is my qualification, you would hire them? What kind of jobs are we looking at today?
So we are looking for data scientists. We are looking for data engineers. And we're looking for cloud engineers as well, because in order to build out these frameworks and these scalable systems and these models, you need cross-functional teams of people who have experience in DevSecOps, people who have experience in data science, people who have experience in machine learning engineering, and then people who have experience in data engineering. You really need, our most successful programs with our mission partners out in the field have robust cross-functional teams of those four categories.
Okay, fantastic.
Yeah.
Back to the government real quick. I'm going to ask which government organizations have shown themselves as early adopters of AI? And I also ask this, I'll add this to it, is because I've asked some of the government officials from an acquisition point to have OTAs because technology is moving at such a rapid pace, but acquisition and policy is still archaic. And what's happening is that by the time they open up a rec, it's already old technology. So it's like you're trying to catch up. So how do you reconcile with these two different rhythms?
So I would say, first of all, the organizations that are leaning heavily forward into it, the Department of Defense, the intelligence community, and even some of our federal civilian partners like the Department of Homeland Security have leaned really heavily into AI. I would say the key is the most successful programs are the ones where they pick, we talked way back at the beginning, right? To bring it back to the beginning, we talked about narrow focused AI. Come with a very specific problem that you want to solve. We don't need to solve world hunger, right? But let's not also solve the easiest problem either, right? So come with a problem that makes sense to solve and then bring the data with it and bring the wherewithal to stick that process out. And each time you solve a problem, you're building on that repeatable framework. And each time you leverage a model, you're actually getting farther and farther down that maturity timeline, and it works out really well.
Okay. There is one more question.
Yes, lots of questions in the chat, so thank you so much. Kathy Bold says, you mentioned that mission partners own their data and don't lose ownership. Does this also apply to technology partners? Does this perhaps allow engineering partners to use the digital thread and protect their trade secrets?
Yeah, that's a great question. We're actually working on a number of programs on the Department of Defense side as well as space technology side. And as you can imagine, that's a real issue. When you have to have multiple organizations working together and sharing information with each other, to build a particular platform or to reach an end goal for the common customer, that's still difficult to do because we're worried about sharing proprietary information or giving away too much. So this idea of using Coverse, right? We'll go back to Coverse for a second, and segmenting that data so that company A is confident and assured that the only information that they're sharing with company B is what they want to share with company B, and company B is equally assured that what they're sharing with company A or company C is also only what they want to share, but then giving access to the customer at large, the government, whoever that customer might be, access to all of the data. And so it really makes it easier to create this auditable, immutable trail and this trust in AI around how we share data across multiple different companies or enclaves or systems.
Great,
Okay.
thank you.
We are gearing towards the end of time. There's one last question. Okay, go right ahead.
Yep, we're going to do one more question, and there are also other questions in the chat that we didn't get to, so we'll try to respond at a later time to make sure we get to everyone's questions.
Okay.
So last question for today is, how can organizations ensure that the AI models used for mission acceleration are transparent, explainable, and free from bias?
Great question. So the short answer is they can use Tenjin. That's what it's been designed for. And the idea, we talked a little bit about the explainability of models. We also have features that allow you to do auditability, to understand in a multi-collaborative, multi-tenant environment, who interacted with the data or the model, when they interacted with it, what the downstream effects were, so you can understand what's happening there. So you have the explainability, which explains what's happening to the data. You have the auditability to understand who's been working with the data. And then you have deep model metrics. So we do a lot of work specific to the models where we look for both in the training phase and in what we call post-verification and feedback. So once the model is operationalized and in use, we have a lot of metrics where we can look for things like mathematical bias or confirmation bias or drift on the models. And again, all of that's abstracted into a way that anyone can understand and digest as well. So again, all of that together really helps to promote this idea of responsible AI, trustable AI, and ethical AI.
Oh, that's fantastic. Yeah, thanks, Jay. Every time I sit down and talk to you, even though it happens often, I still get new information. Hey, this is the latest. This is what's happening. So it's always a pleasure. And to all our viewers, thank you for tuning in with the team SAIC over here in Reston. Feel free to go to our website, SAIC.com or Coverse.com. We will try our best to address anything dealing with data, system integration, any of the services. Of course, artificial intelligence is the hot topic, so come to us anytime, and we're here to help.
Thanks, Manmeet. Thanks, everyone.
Thanks, Jay.